Hey everyone, Professor Lamar here, and welcome to this mini lecture video. Here in this video, we're going to talk about z-scores and the normal distribution, and specifically, we're going to focus on how we can use the normal distribution to make sense of a set of data. Now, before we do this though, we need to actually have a little bit of a review because you see chapters 1 through 3 in our class really lay the foundation for understanding normal distributions and z-scores. So let's talk about some concepts from chapters 1 through 3, and we'll start to connect them to what we're learning now. First, thinking about some descriptive statistics. If you think about what descriptive statistics do, they describe a set of data. And so descriptive statistics are things like central tendency, variability, and frequency. Now, first, let's talk about central tendency just briefly. Central tendency tells us where scores tend to fall in a distribution. If you think about the three indicators of central tendency, the mean, the median, and the mode, they tell us where scores are on average, which is the mean. They tell us the middlemost number, which is the median. And they also tell us the most frequent score, or the mode. All three of these indicators, again, are designed to kind of tell us where scores tend to fall. And the cool thing about central tendency is it's a number. So once we hear that number for central tendency, we can start to kind of visualize a distribution and put some pieces together. We should also think about how spread out scores are. Now, when we think about how spread out scores are, that's called variability. And if scores are really spread out, that means that they're far away from each other, right? If scores are really far away from each other, then the distribution is really stretched, and variability would be a large number. If the scores are tightly clustered together and there's not a lot of space between the scores, then variability is small. Now, there's lots of indicators of variability that we learned about in chapter 3, but the most common indicator, and the one that we're going to work with for the rest of the semester, is standard deviation. Standard deviation, again, just tells us how spread out scores are, but the cool thing about it is that it's in the units of whatever variable we're working with. So if we have a distribution of exam scores, for instance, standard deviation will be in the units of exam scores. So if the average score on an exam, for instance, is a 70 and a standard deviation is 3, then we can start to kind of visualize a distribution of scores on an exam and understand how spread out scores are with that standard deviation of 3 units. Okay, now last though, we've talked about central tendency, we've talked about variability. The third type of descriptive statistic that will be important for us is frequency. Frequency tells us how often a score appears or how frequently a score appears in a data set. So for instance, again, let's say you have 100 students take an exam and the average score is a 70. If the data falls along a normal distribution, then we can also see the frequency of other scores on the exam. Because I want you to picture like a normal curve, just like this here. The line of the curve goes up and then back down, just like a bell-shaped curve. And this line tells you how frequently each score appears. So if you look at this score of 70, let's say this is the average, we can see that this score appears a lot because it is at the highest point, the peak of that graph. Scores on the ends, both the low end and the high end, appear much less frequently because the line of the graph is lower. And so a normal curve, again, this curve right here, is just a frequency distribution. It tells you how often people score certain values with a data set. Now, on these normal curves as well, the 3 indicators of central tendency, the mean, the median, and the mode, they're all the same value, right? And so these are some of the premises that always have to be true with a normal distribution. And that's what we're going to start talking about now. Now, again, the normal curve is bell-shaped and it's symmetrical. And it's symmetrical along this line that bisects the distribution or cuts it in half. This line here, right through the middle of the distribution, this represents the mean, the median, and the mode. But when we talk about it in our class, we'll often just refer to it as the mean. You should still know it's also the median and the mode because the distribution is normal, but you typically will refer to that middle point as the average or the mean. Now, again, this is a frequency distribution. So the higher this red line goes, the more frequent the response, which is kind of cool. And we can see that the line increases and goes up towards the middle and then tapers off on both ends. Now, one of the curves that we're going to work with that's a normal distribution is called the standard normal distribution. This has a mean of 0 and a standard deviation of 1. And we kind of use this as like the guide to map things onto and compare things to. So this will become a little bit more clear in a couple of slides, but we will utilize the standard normal distribution and start to kind of make sense of that as we go. Now, there are 7 different features that are always present in a normal distribution. And again, some of them we've talked about already. We know that there's symmetry here, that the normal distribution is symmetric around the mean. It's also symmetric around the median and the mode because they're all the same value. Now, the next thing though, that's pretty important is that the area under the curve is equal to 1. And I want you to think about this for a second. Imagine you have 100 students who take an exam, okay? 100 represents everyone, right? Because your sample is 100. And this line here, this normal curve that goes up and then back down, this tells you how frequently those 100 people score different responses. The average score on the exam was a 70. We could see that some people also scored a 73, which is located right here. Fewer people scored a bit higher. And then also some people scored a bit below 70, okay? Now, if you think about this curve though, everything under this curve represents those 100 people in the sample, right? And so this curve, everything under it is all of those data points, all those 100 data points or 100 scores on an exam. And so the area under the curve equals 1, because in this case, 1 is a proportion. If you were to multiply 1 by 100, you would get a percent, and 1 times 100 is 100%. So the area under the curve represents 100% of whatever sample or population we're talking about. Again, 100% of the sample or population is under that curve. Now, when we talk about the normal curve, again, we're going to use 2 different parameters. We're going to talk about the average, which is represented by mu. And again, this is talking about like the population for this specific thing, which is why we're talking about mu for this. If we have a sample, then we're going to talk about X bar, which is the average for the sample. And then the other parameter is the standard deviation, which is this symbol here, or also a symbol of S if we have a sample. Now we'll always look at these two different kind of metrics. We'll look at central tendency through the mean and then variability through standard deviation. And from that, we can start to make inferences about the sample or population. One of the first things we'll look at is actually called the empirical rule. And this tells us that 68% of the distribution falls within 1 standard deviation of the mean. 95% falls within 2 standard deviations. And the cool thing is that 99.7%, almost the whole data set, is within 3 standard deviations above or below the mean. Now let's break this down. I want you to look at this curve here. This has an average of 70 and the standard deviation is 3, okay? So if we were to look 1 standard deviation above the mean, we would look at the mean of 70, add a standard deviation of 3, and get a score of 73. So a score of 73 falls 1 standard deviation above the mean. Now my question to you all is, what score falls 1 standard deviation below the mean on the other side? Well, we do the exact same thing. We take the mean of 70, and now we subtract a standard deviation of 3 to get the score that falls below the mean. 70 minus 3 is 67. So 67 is 1 standard deviation below the mean. 73 is 1 standard deviation above the mean. 68% of the sample of 100 people falls within the scores of 67 to 73. Again, another way of saying this is that 68 out of the 100 people scored somewhere between 67 and 73. Kind of cool, right? And again, this is true for any normal curve. 68% of the sample or the population will fall within 1 standard deviation below to 1 standard deviation above the mean. That's awesome. Now, the same is true for 95% within 2 standard deviations. If we go 2 standard deviations above the mean, we take 70 plus 1 standard deviation of 3 plus another standard deviation of 3 because we want to go 2 standard deviations above. And we get a score of 76. So 76 is 2 standard deviations above the mean. Now, what score is 2 standard deviations below the mean? Well, we would take 70 minus 6, and we would get 64. So that means that 95% of the sample scored somewhere between 64 and 76, which again, pretty cool. 95 out of the 100 people scored between a 64 and a 76. Awesome. Now last, 99.7% of the sample is within 3 standard deviations of the mean. So 3 standard deviations above the mean is 70 plus 3 plus 3 plus 3, which is 79. And then if we go 3 standard deviations below the mean, we have 70 minus 3 minus 3 minus 3, which gives us 61. So 99.7% of the sample, almost everyone, should score between 61 and 79. Again, pretty cool that we can start to see this. Now, this 68, 95, 99.7, like these 3 metrics, they're called the empirical rule. And so sometimes it's also called just 68, 95, 99.7 rule. And it allows us to understand the percent of the sample or population that falls within each standard deviation of the mean. Now, another really cool thing about this is that we can start to pick up on outliers using this rule. You see, anything that's more than 3 standard deviations above or below the mean is considered an outlier. And if you think about why, 99.7% of the sample falls within 3 standard deviations. So if something is more extreme than that, well, it represents a very small percentage of the sample or population. And it's so extreme that it's just not like most of the data, 99.7% of the data, which is kind of cool. Now, I want to show you one more thing though. Here we have another normal curve, okay? And I want you to take a second to look at the metrics from the normal curve we were working with before, again, which has a mean of 70 and a standard deviation of 3. And this new normal curve. You can see that the average is the same, right? They're both an average score of 70. But in this new curve, the standard deviation is 12. It's a lot larger than 3. Think about what that means. If the standard deviation is 12, that means that scores are much further spread out. So if we were to look at this new data set and look at the score on the exam that's 1 standard deviation above the mean, it's a score of an 82. An 82 in this case is 1 standard deviation above the mean. And so this is how we start to kind of use the mean and the standard deviation to make sense of a data set. We can see that when variability is high, the standard deviation is a larger number, and this means that scores are really spread out, right? When standard deviation is low, it's a smaller number, and scores are more tightly clustered together. Not only that, but we can start to use that empirical rule to understand the percentage of the sample that falls within 1, 2, or 3 standard deviations of the mean. And that's what I want us to get a little bit of practice with in this case. So let's say that we have a distribution and it has a mean of 50 and a standard deviation of 5. I'd like you to take a second to use this normal curve here and answer the following questions. What score is 3 standard deviations above the mean? Next, how many standard deviations from the mean is a score of 35? And last, would a score of 30 be considered an outlier? Why or why not? So again, I would encourage you to pause the video here, actually draw a normal distribution on whatever you're taking notes with, and then map out the mean of 50 and a standard deviation of 5 to start answering these questions here. Okay, I'll give you a second to pause that video. I know we all will. And then when you're finished, you can hit play again. Okay, so I'm assuming we've started to answer these questions, and now it's time to go through the answers. You can see here, we have that normal curve we were working with, and I drew a line down the very middle that represents an average score of 50. We know the standard deviation is 5, and so our first question here is what score is 3 standard deviations above the mean? Well, to know 3 standard deviations above the mean, we would have to take 50, add 1 standard deviation of 5. So 1 standard deviation above the mean would be a score of 55. The next one would be a score of 60. And then 3 standard deviations above the mean would be a score of 65. Again, we just got that because the standard deviation is 5. So 3 standard deviations above the mean, we take that average of 50 or the mean of 50, and then we add 5 plus 5 plus 5. 50 plus 5 plus 5 plus 5 gives us 65. Okay. Next, how many standard deviations from the mean is a score of 35? Okay, so here's our score of 35. And we have to think, okay, how many standard deviations is it from a score of 50? Well, 50 The difference between 35 and 50, like 50 minus 35, is 15. Now 15 is 3 standard deviations. Again, a standard deviation is 5. So if the distance between 50 and 35 is 15, 15 divided by 5 is 3 standard deviations. So again, if you think about going 3 standard deviations above the mean, we get a score of 65, and that's also 15 points away from 50. And if we look below the mean at a score of 35, that's 15 points below 50, or 3 standard deviations below the mean. Now, last, would a score of 30 be considered an outlier? Well, if 35 is 3 standard deviations below the mean, and anything further than that is considered an outlier, then yeah, a score of 30, that's more extreme than that 35. It's further away from the mean, which means that it's more than 3 standard deviations away from the mean, and therefore an outlier. Okay, so to recap for this mini lecture video, by the end of this video, hopefully you can visualize a normal distribution, and understand where the mean and the standard deviation would fall on that distribution, and can kind of interpret that and visualize that. Next, if you have a distribution that's normal and you know the mean and the standard deviation, are you able to determine a score that is so many numbers of standard deviations away from the mean? Like if you say, what score is 1 standard deviation above the mean? Can you calculate that? And then next, can you determine how many standard deviations from the mean a score would fall? Like if you have a score of 35 and the mean's 50 and you know the standard deviation is 5, can you determine how many standard deviations from the mean that score of 35 would be? Okay, this brings us to the end of this mini lecture video. And if you do have any questions, as always, don't hesitate to reach out. But otherwise, I'll see you in the next mini lecture video. All right, bye everyone.